Hello everyone, welcome to the third episode of Rendezvous with the Stalwarts, the show where we discuss the journey of stalwarts in our profession and talk with them about their experiences, projects, and their vision for the future of our industry. I am Daniel Couture, your host for the show, and in today's episode, I am very excited to be talking to Kevin LaMalva. Kevin has over 13 years of experience as a structural fire consultant in the US. He is also one of the past chairs of ASC SEI Fire Protection Committee and also a member of numerous industry committees that conduct research and develop standards for structural fire safety. For his work in structural fire safety, Kevin has been awarded the distinction for Engineering News Record Newsmaker for serving the best interest of the construction industry and the public. So let's dive in straight to our conversation with one of the most passionate advocate of structural fire engineering. Welcome Kevin in today's episode of Rendezvous with the Stalwarts. It is truly a pleasure to be talking to you on the show today.
Pleasure on my end as well. Thank you very much for that kind introduction. And I'm really excited to be part of this dialogue with you today. I think that, Daniel, you've really built a really awesome platform for structural fire engineering dialogue. So I'm privileged to be a part of that. And hopefully I can inform your audience on a subject I'm very passionate about.
Surely, surely. Thank you for your kind words. So, Kevin, I'd like to start from your schooling years to know more about which were the professions you were interested to pursue as a career in your growing years and what inspired or drew you to pursue a profession in civil and structural engineering.
Yeah, I appreciate that question. It allows me to be a little nostalgic. Um, I'll go back to what I think was sort of my first career ambition, which is going all the way back to elementary school.
Okay, sure,
I
sure,
thought
sure.
I wanted to be a cartoonist and maybe work for Disney one day.
Oh,
Um,
great,
I would,
great.
yeah, I would spend a lot of time coming up with cartoon characters, and I even made these sort of clay figurines with all these different expressions. And I sort of thought I was going to build a business of selling clay figurines, but I guess that sort of burned out. I didn't pursue it quite forcefully enough. But in
Okay.
elementary school, in my art class, I recall, a painting of mine making it into the Worcester Art Museum. So that was sort of my first taste of a passion that can then be recognized. So
Okay.
that sort of fostered my creativity there. And when I moved on into middle school, I developed a real liking for technology and shop classes. And I remember that the teacher would give us just an open-ended problem, and the teacher would say, okay, well, think about it and then draw it and then build it. And we would have to sort of go around the shop facility finding materials and machinery that could be used to form the materials how we want, so to come up with a better mousetrap. And I really grew a liking to that sort of problem solving,
Yeah,
finding
yeah.
solutions to problems that are not readily apparent. And I've had the privilege over the past 13 years to do that on a day-to-day basis, so it's been really nice. And actually, in middle school, based on my work through those series of classes, I actually was given the engineering student of the year. So I was, again, that sort of helped back my ambition to go into that area. And at the same time, my cartoonist and creativity aspirations were transitioning into more of the sort of hard technical classes. I took a
Yes.
liking to physics, and I placed in our science fair. And, admittedly, up to that point, my grades in, middle school or, before that were relatively mediocre.
Okay.
And I remember my parents offering me $20 every time I would make the honor roll. And I thought to myself, I'm like, that adds up to $80 in a year. And,
Yes, yes.
that's quite that was a big sum of money to me back then. So,
Yeah, yeah.
from that point forward, I actually made honors every single semester all the way until I graduated. So, the combination of gaining interest and also having some motivation, I think, with the prize power, um, sort of propelled me to that point. So then I,
Okay.
seriously started thinking about college, and I know I wanted to go into engineering because I, wanted to apply
Yes.
my creativity, problem solving.
Yes,
And I
yes.
remember having a conversation with a guidance counselor and said, I want to go into engineering. I'm not sure what, one to go into. And the
Okay.
guidance counselor was like, do you want to work on something big or something small? And that will help narrow it down. And, of course, I said, I want to work on something big.
Yeah,
And he's
yeah.
like, okay, well, civil structural, we can work on buildings and bridges and infrastructure, is probably, the way to go. And actually, I have an uncle who's a civil engineer, so I was able to,
Okay.
pick his brain a little bit, and
Yeah,
he's
yeah.
happy in his profession. So, overall, that inspired me and sort of put me on a track to study civil structural in college. Again, going to my strengths of problem solving, as well as the sort of added benefit of my creativity, sort of set me on that
Okay.
path to structural engineering.
Okay. Okay. So, Kevin, you have been a passionate advocate of fire engineering from for quite a number of years now. So, I'd like to know what drove your attention towards fire engineering after getting into civil and structural. So, fire engineering is a very particular niche which did not have much recognition earlier. So, what inspired you to take up this niche, or what it was that ignited your passion for fire engineering?
I like the word ignite. That's a
Yeah,
good segue there.
yeah,
Yeah,
yes,
fire.
yes.
There's much less fire engineers in the United States than structural engineers. It
Yes,
is much
yes,
more of a niche discipline.
yes.
Um, but I would, I remember sitting in high school when the events of 9/11 happened,
Okay.
and myself, along with others that have sort of flocked into structural fire design, that are of a similar age as I. I commonly hear, and this is what sort of inspired me, is that I looked at the fires in those buildings and the collapses and the tragedy, and that I looked at that as a problem.
Yes, yes,
Not only the twin towers, which had impact and fire, but World Trade Center 7 was a building that collapsed, and it only had uncontrolled fire. There was no impact,
yes,
direct impact from aircraft. So
yes, yes.
I already knew I wanted to go into structural engineering, and I thought to myself, I'm like, are these buildings structural designed for fire? Um,
Yeah.
so I had a variety of choices of colleges and universities to attend that I got accepted to.
Okay.
Um, and I settled on Worcester Polytechnic Institute, WPI,
Okay.
because I found out that they have a fire engineering program. And they also offer structural engineering. Now again, they weren't sort of, and they
Yes.
currently are not to this day synergized with each other. But
Yes.
I
Yes.
thought maybe I can sort of dabble my toes in both. And also WPI, I'm from Central Massachusetts, and that's where WPI is. So
Yes.
it gave me an opportunity to commute to school, which saved a lot of costs, which was important. So I, began as an undergraduate civil structural, and I remember my first semester. The common track of an engineering student is you take more abstract classes at the beginning and you transition
Yes.
into more specific. And I really struggle with those abstract classes at first, such as calculus and differential equations and such. And
Okay.
I was struggling halfway through that first semester, and I was thinking to myself, am I really cut out for this? But a godsend for me was I found out about a program at WPI called MASH, Math and Science Help,
Okay.
where teaching assistants would provide their time to help mentor you to understand these concepts and to do better on your classes.
Okay.
So I took full advantage of these MASH sessions. I went to pretty much every one that they offered. And it goes to show you that, the power of reaching out for help, because
Yes, yes.
from that point forward, I had a 4.0 grade point average throughout my
Oh,
undergrad and graduate. So it didn't come easy to me, and things don't necessarily come easy to me, but
yes,
I'm
yes.
definitely not shy to reach out for help. So that's something that helps. And during my undergraduate tenure, I
Okay.
was really fortunate to have sort of my first great technical mentor, Professor Fitzgerald. People called him Fitzy. And he recognized my passion for structural fire engineering. And although WPI didn't have a structural fire engineering track, he tailored my curriculum to be a mix of both structural engineering, mechanics, dynamics, with thermodynamics, heat transfer, things that a structural engineer would not necessarily take,
Yes,
to
yes.
give me a nice mix to then
Yes.
be in a position to practice structural fire engineering. So that was extremely helpful to me.
Yeah, definitely.
And yeah, and also Professor Fitzgerald opened up doors and made introductions to get me summer internships, that ranged from both fire engineering office work
Okay.
to being actually an apprentice fire inspector, where I get to get my hands dirty and get into buildings around Massachusetts and Connecticut. And he really put me on a good track to be motivated, to study, to get help, to get that real world experience. And by the end of my undergraduate, I was nominated by the civil department to receive the WPI Salisbury Prize. And
Okay.
that was another instance of my hard work sort of coming
Yes.
to fruition, and really reinforcing that, that there's a lot of benefit there. Um,
Yes.
and then I transitioned into graduate school,
Okay.
and I came across and was taken under the wing of another great technical mentor, um, Professor Barnett. He was a professor in the fire protection engineering department, and it really started in his building code class, where we got to structural fire protection in the code, and I was really struggling with one of his assignments because I kept trying to relate what was building code requirements to actual structural engineering performance, and
Okay.
I was asking provocative questions in the assignment. And although I got the assignment wrong, I didn't do well on that assignment. He really appreciated me thinking outside the box on this, and he became aware of my really good grades, and then he recognized my passion in the area. So what he told me, he says, I'm going to task you with an ambitious master's thesis project, and
Okay.
I'm going to make you my teaching assistant. So, I was really blown away by this opportunity. It
Yeah.
was a pet project of his that he really wanted answered. And Professor Barnett, was on the World Trade Center investigative team as part of
Okay.
FEMA. So he was actually on the ground investigating those collapses shortly after. And I recall him giving me actually a piece of the World Trade Centers that was a specimen, and I sort of, I kept that as sort of symbolism and motivation for finding good answers to make buildings more resilient to fire. So he, at the beginning of the project, he implored me or encouraged me to make a Freedom of Information Act request to
Okay.
actually get the building plan. So the master's thesis topic was to investigate the internal structural collapse of World Trade Center 5. So eventually, my thesis was published in the Journal of Fire Protection Engineering. I also was given an award by the Society of Fire Protection Engineers for the work, and they
Okay.
invited me to Las Vegas to present it. And again,
Great.
when I presented it, people came up to me afterwards, and they said, "This is like a NIST investigative report." So,
Yeah.
it really reinforced that, this is really my calling,
Yes,
and there's
yes.
so much more to do and it sort of
Yes.
motivated me to continue,
Yeah.
down that area of fire engineering.
Yeah, that's an encouraging story. Like your professors in undergraduate and graduate courses as well, like give you a lot of practical experience, and together with your hard work, you were more inclined towards fire engineering and you excelled in that.
Exactly.
Kevin, could you briefly describe for our listeners like what is structural fire engineering and why do we need to insulate our structures with fire protection? Like what can structural fire protection provide to our structures?
Yeah, no, that's a great
Yeah.
question. I think I'll address the question first about why do we
Yes.
thermally insulate structures and how do
Yes.
we traditionally do so?
Yeah. Yeah.
We traditionally insulate structures with fireproofing in order to lower the temperature of individual parts of the structure
Yes.
to an extent that we hope will provide sufficient resilience under fire. So,
Yes.
I say it's sort of spray and pray because you're not actually doing the structural analysis, but you're
Yeah.
actively trying to lower the thermal demand. And what are we
Yes.
really protecting against? We're protecting against uncontrolled fire. And
Yes.
uncontrolled fire in a building is actually quite rare. Fire sprinkler systems are very effective at controlling a single fire that's ordinary during its incipient phases. And I've actually
Yes.
had the
Yes.
opportunity to design sprinklers. And hydraulically, they're only designed, unlike what you see on Hollywood movies, where the actor puts a cigarette lighter up to a sprinkler and then
Yeah.
they all go off.
Yeah.
Hydraulically, they're not designed that way.
Yeah.
They're actually only designed for a small number of contiguous sprinkler heads to activate to control one fire in one location that's relatively normal.
Yes.
Because if you look at the branch line piping, it's economically sized and,
Yeah.
it's on
Yeah.
the order of a half inch, maybe 3/4 of an inch. So, you can't have all the sprinklers going off at once.
Yes. Yes.
And, but there may be cases where the hydraulic capacity of the system is overwhelmed by a very severe fire, where the fire is able to grow uncontrolled even when there is a sprinkler system.
Yes.
Also, there may be potential accidental occurrences, such as valves being accidentally shut off during inspections and maintenance. Lack of maintenance of the sprinkler system can cause problems. There's a lot of working parts with sprinkler
Yes.
systems, especially dry pipe systems. So we're really, once that sort of first line of defense is breached, then the structural system is relied upon to protect building occupants and firefighters, and also just the community as well. We don't want structures
Yes. Yes.
collapsing under uncontrolled fire.
Yeah.
So I said that the spray aspect, that's really looking at the demand side of the equation.
Yes.
Fireproofing is typically qualified using a furnace test that's remained relatively unchanged since 1918. So we've gone past the 100-year anniversary. And actually, I gave a presentation at an ASTM conference where they
Okay.
were celebrating the centennial anniversary of the way we qualify fire resistance. And it was interesting because I
Yeah.
was basically conveying that we have to think of other methods.
Yeah. Yeah.
And in furnace testing, essentially a single mock-up, either a single beam or a single floor segment is placed within a 14-foot by 17-foot furnace,
Okay.
and then it's exposed to a relatively intense heating exposure. And the acceptance of the test is primarily thermally based. So if the temperature of the structure itself doesn't exceed thresholds, both spot and average,
Okay.
that's the point that they stop the test, and that's sort of the hourly rating that you get, whether it be 30 minutes, 1 hour,
Yeah.
or 2 hours or 3 hours. But
Okay.
furnace testing has many limitations, which I could probably speak the whole segment on. So I'll keep it brief.
Yeah. Yeah.
It doesn't include structural connections. It basically, the assembly just sits on a shelf. It doesn't account for the restraint accurately of how the structural system, sort of how that mock-up would fit within a structural system. And it also
Okay.
doesn't represent a realistic fire, because it's just a fire that just heats and goes on, where a real fire kind of heats up
Yes.
higher at first, but then declines. So
Yeah. Yeah.
there's a heating phase where the structure is primarily trying to grow, and then a cooling phase where it's contracting again.
Yes. Yes.
So the way that, an analogy to think about is, the way that we prescriptively um, prescribe fire protection of the structure is almost like getting a UL rating for a shovel, and then assuming that that UL rating provides a level of safety for a plow truck. Yeah, it's like, the scope of a furnace test is so much different than what what manifests itself in a structural system. And that leads me to, what structural fire engineering is, and how it can be provided.
Yes.
Um, structure, to go as a segue from how we traditionally do it, um, it's structural fire engineering is essentially the design of structures for those fire effects. So it's being active, it's being proactive. Um, and we're hoping that we can put it on a similar footing. And again, we're very envious of these disciplines of performance-based wind and performance-based seismic. So, we envision there'll be one day where structural engineers consider earth, wind, and fire. So that's sort of the elevator pitch that
Yes.
we're giving the structural engineers, which is a little catchy.
Yeah.
At the same time, we want to empower structural engineers. We want to transition structural engineers from onlookers that are not actively involved in structural fire protection to integral participants in structural fire protection design. So,
Yes.
how can a structural engineer add value in that sense?
Yes.
Um, a structural engineer can make modest structural enhancements that make the structure more intrinsically safe to fire without necessarily relying exclusively on the fireproofing. And there's many
Yes.
opportunities to reduce the extent of fireproofing, because the structural engineer is considering the demand side and the capacity
Yeah.
side. One example of that is making upgrades to the welded wire mesh reinforcement that are already present in most composite slabs,
Yes.
perhaps increasing the density a little bit and lowering them within the profile of the slab in order for the floors to perform better as membranes. So
Yes.
allowing them, they're inevitably going to undergo high deflection under fire.
Yes.
So those upgrades can actually make the floors stronger and stronger as they deflect. Almost like if you take a bicycle wheel and you hold it horizontally and you push down on the center hub, you
Yeah.
can create a tension zone that's strong enough to carry that to the rim. Then the rim equilibrates that with compression.
Yes.
And
Yes.
that has benefits beyond fire. So we can really benefit public safety with structural engineers being involved. And at the same time, it gives a lot of opportunity to deliver more efficient, economical, and rational design, just like we do for other design hazards. And,
Yes.
depending on the design, you can have an enhancement to the economics of the project, the carbon footprint, because you're using less cementitious material, the aesthetics, you can have exposed steel in a lot of cases,
Yes.
quality control, because you can engineer your applied fire protection solution perhaps to be done off site, and that can help with site conditions and life cycle maintenance, making it less of a concern for the building owner.
Those are some great points. Thank you for like briefly explaining the entire process behind structural fire engineering.
Well,
So,
absolutely. I'm a junkie on the subject, so I'm happy to always talk about it.
yeah. Is the demand for structural fire engineering driven mostly by the codes and standards, or like do the project owners also have a hand over it?
Yeah, so the US is a little late to the party in this respect. Structural fire engineering has been, performed abroad for, at least a decade. Europe,
Okay.
the Middle East, Australia, to name a few, Japan. And the company that I work with, Warrington Fire, um, I was actually their first U.S. hire,
Okay.
because they're very hopeful that the technology that Warrington Fire has, practiced over the years can really be employed in the United States because the conditions are very right for that.
Yes.
As we'll probably talk about, I've had some opportunities to do structural fire engineering, and structural fire engineering essentially provides project stakeholders an alternative to the prescriptive code requirements. So
Okay.
it essentially must be proposed as an alternative means and methods, and it needs to be negotiated. Um, it's not like doing a conventional structural design where we're going to do this to AC7 and there's no questions asked. A structural fire design, because it's an alternative, you have to have that dialogue with the building authority, and that's where being a diplomat as well as a person that is confident in the technical material becomes important, because you really have to be able to have a frank discussion with the stakeholders, which may have varying motivations.
Yes.
So the billing authority is primarily going to be concerned about, does this alternative method truly provide a reliable, safe design?
Yeah.
So you have to keep them involved throughout the process and be as transparent as possible to give that level of assurance. And structural engineers are wonderful to fill that role because we are
Yeah.
conservative by nature, and we're trusted with high-rise buildings to withstand earthquakes. So
Yes.
we're a wonderful group of engineers that can step up to this.
Yes.
And in terms of the benefits to the industry, I think it would certainly benefit the architectural engineering construction industry overall, because
Yeah.
it it's been demonstrated to provide better performing and better optimized buildings. And also, it can provide an entry to certain innovations that wouldn't otherwise be allowed under prescriptive structural fire protection. Because
Yeah.
if you think
Yeah.
about it, we optimize structures, and we do it in a performance-based sense, even not the pseudo, the advanced performance base, but we're still applying mechanics to a structure, and we're allowed to make the structure, how we envision, just as long as we trace loads to the ground and consider the right loads per AC7.
Yes. Yes.
But what we end up doing is we make that sort of 21st century technology with 20th century technology of structural fire protection. This gives a rational way to synergize the two better. And
Yes.
because we're confirming the intrinsic safety of the structure, I'm very hopeful, and there's been cases of this that I've experienced, where the building authority is receptive and appreciative that you've identified any fragilities that there are and you've properly addressed them in a structural
Okay.
engineered sense. So I'm hoping all those things will drive demand.
Yes.
It's in the United States, it's certainly within its infancy, but
Yeah.
there's a wonderful opportunity, I think.
Yeah. Thank you so much, Kevin. That brings us to the end of our conversation for part one. In the second part, we'll be discussing with Kevin about his interesting projects and the application of structural fire engineering. See you all in the second part of our conversation with Kevin.